All right, here. So we have a point that's moving along the curve in this quadratic function. So if we just make a quick sketch of what this would look like. Here is your quadratic function. Let's move 4 units to the right here at 4. And your point is moving on the curve such that the x-coordinate is decreasing at -3 units per second. If your x-coordinate is decreasing, you have to be moving this direction here along your curve. All right, we're going to focus on letter B, and it says at the moment that x equals 2, so I'm looking directly here at this time 2, or not time 2, excuse me, that the moment that x is 2, we want to know how fast is the point's distance from the origin changing. So we're looking at the distance from this point to the origin. So I'm going to go ahead and just make this diagram a little more clear. So if we're talking about distance, I'll just call that distance being large D. And we have x here, and we have y here. Well, we know what y is because we were given the equation. So the equation is y equals 4 minus x squared. So if I wanted to eliminate some variables, I could just say, instead of calling it y, let's call this 4 minus x squared. And now from here we can come up with an equation. We're looking for this distance, the rate of change of the distance from the origin. So we can just do that with Pythagorean theorem. So our distance squared equals x squared plus our y squared, which ends up being 4 minus x squared squared. So I'll simplify a little bit here. Distance squared is x squared plus 4 minus x to the 4th. And now since we're looking at rate of change, of course, we're going to implicitly differentiate. So with respect to time, we're looking at a moment in time. So this becomes 2d dt equals 2x dx dt plus, bring our 4 down, so we have 4 minus x to the 3rd. Chain rule, times it by -1, but don't forget, times it by dx with respect to time. And now we can just do some substitution. Well, we can find our d value pretty easily because we're looking at the moment that x is equal to 2. So if I'm looking when x is equal to 2, that means I have a 2 here, substitute my 2 in here, I end up with 4. I can find d because it's a squared plus b squared, so d squared actually just equals 4 squared, which is 16, 2 squared, so 20. So d is just root 20. So I have 2 root 20. Remember, we're looking for the distance, the rate of change of the distance, so we're going to solve for dd dt. 2 times our x value, we already know that. X is 2. We have our x coordinate is decreasing at a rate of -3 plus 4 minus 2 to the 3rd, -1, the rate of change, -3. And now it's just some calculating here. So I have 2, I'll go ahead and simplify that. 2 times 2 root 5 dt. This ends up being, here we have -12, and this ends up with an 84. Do some rearranging here. So dt is 84 divided by 4 root 5. I can simplify this to be, let's see, actually we can just go ahead and call that 21 over root 5, which is 21 root 5 over 5. And that's our rate of change. So we would have to say at x equal to 2. The distance from the origin is increasing at a rate of 21 root 5 over 5 units per second.